Welcome students. We begin this session of electrostatics with the subject of electric field. Now you see, field is a very kind of a imaginary concept. Well, but as you know, according to the great scientist Albert Einstein, imagination is more important than knowledge. So in that case, we need to understand that whenever you place a charge, you have a field. Now the field theoretically extends to infinity. So here is my circle, which actually I indicate till infinity. Now if you want to measure this field, all you have to do is to introduce what we call a test charge. Now a test charge is primarily a one which has a polarity or a sign of plus and the magnitude of 1. So a test charge will be always positive in nature and having a magnitude of simply unity or 1. Now, as you place the test charge in a field, what eventually happens is that the charge due to which the field has got created will either attract or repel this test charge, which you now give a value of small q. So you see, if this charge is positive, then this will be pushed further away and it will be repulsive. And if this is negative, then it will be attracted towards the charge. Now this force with which the test charge is either attracted or repelled is what we call the intensity of the field. So, dear students, the intensity is actually the measure of the field. In many problems, you will find that what is the magnitude of electric field? The electric field magnitude means nothing but the intensity, which we give with a capital E, which is force F by the magnitude of test charge, mind you, which is small q. So it is very important for us to understand that this q is the test charge. And when we define electric field, we say that it is nothing but the force acting on the test charge. So mathematically, when we put this together, what we can write from this E is equal to F by Q is the relation that F is equal to QE. And as you know, these are vectors, so we can put them as vectors. But what is more important is the fact that F is equal to QE is the gravitational analog of F equal to mg. How? As we have already said, that electric charge is nothing but an equivalent of mass, and intensity in case of Earth's gravitational field is nothing but acceleration due to gravity in gravitation. So in many problems you have to equate these two, where you have to equate QE and mg together. I will just give you an example to make this thing clear. Say for example you are asked to make an electron float above ground. So how you would like to keep it? Well, in that case you have to apply a force in a direction up which balances the weight of the electron which acts down. So in that case you can equate these two in order to find the electric field required to balance the electron or keep it afloat. In that case, the mass is the mass of the electron and the charge is the charge of the electron. So these are very important cases as we come forward to learn that these two are very equivalent in two kinds of fields, gravitational and electrostatic. Now the second thing about the field is the fact that the field has a very peculiar, I will say, property of getting superimposed. Well, how it happens? Let's check out. Say I have a charge here, I have a charge there, and another charge there. So this is Q1, this is Q2, and this is Q3. Now what I will do is I will try to learn that how they interact with this mother charge, Q. So I will have an intensity due to this charge here, due to this charge here, and due to this charge here. So all I do is to find the total intensity of the field is to add these intensities together, and that too vectorially. So I add them E1 plus E2 plus E3. Now, as we have just discussed that our field extends to infinity, so if I have an infinity here, then how many points do you expect in that infinite field? Well, I'll say that infinite number of points. So you see, it is not just possible for us to join all those infinite number of points together to find the total field. So this total field is just an imagination and cannot be calculated in practice. So we say that field is an imaginary concept. I hope you got the bottom line, that why field is an imaginary concept. I will again ask you to recollect the fact that our field was extended till infinity, so it contains infinity number of charges, and according to principle of superposition, if I am asked to find the total intensity of the field, then I have to add all the intensities together, which is impossible to find out for infinite points. Hence, as this cannot be calculated, we come to the conclusion that field is an imaginary concept. That's all about field. Thank you. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.